Second.
Basically, to incorporate a tuple where um, we store the actual path to the variable to the member of the composite data type that is actually being used as an upvar for the closure.
Right. Are you able to SSH into that?
Let me. Do I need to install something with SSH? All right. Yeah, I can see your screen.
Okay, what do you see here? Do you see this? Do you see a bash prompt now?
I don't see a prompt. I see Athena.
Yeah.
Like means by that I mean I don't see the dollar prompt of bash, but I see Athena.
Well, that is my prompt. That's fine.
Nice. What does Athena mean?
It's the name of the computer in this case.
Oh.
Okay, let's see. Trying to find a good directory to do this in. This will do. Okay. So let's make a new branch. Call this closure upvar tie tuple something. Okay. So, right. So the idea was we're going to try to get started on. Let me just get this. We're going to try to get started on refactoring the upvar types so that instead of having one type parameter per upvar, we have a tuple. And we hope that this is going to work. I think I thought it would. We'll see what happens.
I think based on what we discussed, the only hindrance we had was that the tuples are type checked later or something. You said that problem we have to overcome. I don't exactly know.
No, I'm not sure what I was talking about, but so just to make sure we're on the same page, like why we're doing this is that we want to change it so that in order to figure out how many type parameters a closure type has, we don't have to know how many things it captures because we want to figure out how many things it captures during type checking and not beforehand.
I see.
And the reason, that lets us construct closure types. And right now, this is sort of a closure type is sort of conceptually a struct like this, right? And so what we're basically talking about doing is changing this like so. So now we still have this basically all the same information, but the number of type parameters is not dependent on the number of upvars. It will always be the same. But the arity of this tuple is dependent. But that, I think, is not a problem. You, of course, couldn't actually write this struct definition in Rust because, like, this is really a type parameter like u tuple or something.
Yeah.
So one of the things I was saying, I think we can maybe just cheat because it's not really a struct in the compiler. So I think we can actually cheat, but if we didn't want to cheat, I think we could also do this. That is to say, we could sort of change it so that it has a single field of type tuple, and then everywhere there are parts in the compiler which refer to fields of a closure to name the upvar, so it might be like closure.0 to get the zeroth, or .1 to get the zeroth upvar, and they would become closure.0.1, so that we go through the tuple and go to the first field of the tuple. I think we can avoid doing that, and if we can, I would, at least for the first round, prefer to do so.
Okay.
So it's sort of cheap, as I said. It's not actually something you could make in Rust, but that's okay.
So can I ask a question? So in this struct closure, the first fields are lifetimes. T0 to Tj are the types, and then Ck, Cs are what are those?
Yeah, it's right here. So,
Your signature.
so CK is a type that we use to represent the closure kind.
Oh, okay.
We use a kind of random scheme. Basically, it's always an integer type. So it's either I8, I16, or I32, and if it's I8, that means function u, or function 1. So this is really like an internal thing. It's not something the user ever knows or sees. And similarly, CS is the closure signature, and it's always a function type.
I see.
So we're kind of packing a lot of information into this struct in the form of types because it's convenient to do that.
And so that's why the arity of the tuple will be the closure signature. Okay, so today it does not take the upvar. Oh, upvars are part of. Okay, I see. All right.
This would probably be. Yeah. So CU represents the closure upvars.
I see.
It is always a tuple with. Can we do this?
Yeah, I can see this.
Yeah, no, I'm just thinking if we're going to be able to get away with this, or if we're going to have to change. Maybe we should. I'm trying to decide if we're going to be able to get away with the upvars as fields that reference sort of subparts of this tuple. I'm not sure. I guess we'll find out.
Yeah.
It might be an alternative. Might be to first refactor the upvars and introduce the tuple, which we could do.
Right.
Like this. Well, basically we could start by leaving this part as it is, and just refactor this to be upvar tuple. See what I mean? And then we'd have to refactor all the things that reference those fields to go so that they reference like foo.0. Whatever. But then it would be very easy for us to do the next step.
Okay.
But I'm not sure. The only reason I'm hesitant is that maybe it's not so bad. I think most code sort of doesn't care. Like it wouldn't be so hard to introduce this tuple field. It's mostly, I think, the mirror. There's some special case code in the borrow checker, especially for diagnostics, that tries to identify accesses to upvars. And that code would have to be adjusted. That's not so bad. I guess we should see.
Okay.
It's kind of the answer. Give me a second here. Let's see. So if we I'm trying to remember how this works. I think right. So let's do a little more background. So the closure subst, a closure type, first of all, is defined. Where are these stupid things? Right, so these are all the variants of types that we have in the compiler. And you see closure is here.
Yeah.
It has a def ID and it has one of these structs. And these are just a new typed list of type parameters. Like subst is just the usual list of values for type parameters that we use elsewhere in the compiler. But we wrap them in this struct to kind of give it some extra interpretation that these are specifically a list for closures. And then there's some helper methods.
So is subs like a mnemonic for something or
Substitution.
substitution? Okay.
So because you substitute, like if you have something like this, then when you have foo of U32, T gets substituted for U32.
Right. Yep.
So one of the things you can see that you have is this function upvar ties, which says, given a closure substs, you can get out the types of every upvar. Right? And right now, all that does is call split, which basically takes split takes the list of type parameters and breaks it up into categories. Right, the closure kind. This is that CK up above. The closure signature, and a variable length list of upvars. And then we just iterate through that list to get the list then of all the upvar types. We iterate through that list and downcast it. So have you seen this type kind before?
Yeah.
It's either a type or a region, basically. Right?
Oh, okay.
And so here we're just saying, normally in the list of substitutions we have kinds because they could be lifetimes and they could be types. But we're saying the upvar should always be types. This is the type of each upvar. Okay. So if we wanted to change this, basically what's going to happen is instead of returning a slice here, we're going to return a tuple type, right? But let's do a little more reading. So upvar ties, this is the function that gives back the types of each upvar. I want to see kind of where it's called from.
Okay.
So, because the reason I want to see is if we change this to be a tuple type, and then down here, we're going to basically have to check that it is a tuple type, and then iterate over its contents, right? And the trick part, so it's actually sort of similar, right? So this function, closure signature, gives back the signature of the closure, like its argument types and its return type.
Mhm.
And it works in a somewhat similar way. So it gets that type CS from the substitution.
I see.
It checks, it says CS, this is basically saying CS must be a function type of some kind.
Right.
And then it extracts the signature from there and returns it. Right? And otherwise it aborts. And we're going to do we would do something similar. Like here, we would sort of say match upvar times.sty, and we would expect type tuple. Right. And this basically gives us the same thing as the upvar kinds used to be. But there's a kind of catch. Yeah, there's a slight catch, which is it's actually the case that when we first create the closure, or when we first create an instance of the closure type during type checking, we don't know yet, for example, what kind it is, or what its signature is, or we would like it if we don't have to know how many upvars it has.
Right.
That's the whole point of this. So that means that actually this type isn't always a tuple. It's either an inference variable or a tuple.
Oh, yeah. I think you were referring to this one.
Yeah, and so actually, like, this is true also for the closure sig. So you can see here, there's some comments that says only usable outside of an inference context. And we enforce that by taking this, as it happened, like by taking it, using some lifetime tricks as it happens. But the reason for that is because of this problem of you may not, if you haven't fully completed type inference, you may not know the closure signature yet.
So, can you also briefly talk about the inference stage of the compiler? Like, I don't really understand that.
Well, I mean, sure. So, inference is where we figure out types, and that are not explicitly written. The way it basically works is that you make these things called variables, which represent some type not yet known.
I see.
And at some point or another, those variables get bound, which means that basically we assign them a value. So we say this is the type that we figured out the type now. But in the meantime, you can sort of use these variables. So you might make a variable. Usually, I denote these variables using a Prolog-like notation, like question mark x. So you might say, okay, we'll make a type. We're going to call it question mark x, and then I can use that type in all kinds of places. So I could say like if you wrote this, you might say, what is the type of x? Well, it's question mark x. It's something I don't know yet. But then somewhere along the line, that will get unified or bound with U32, and now we can resolve it and find out what did it get bound to. And that's that write back phase that you modified. That's exactly what it does.
Okay.
It goes through and takes all the type variables and replaces them with their ultimate value.
Thanks. Thanks a lot.
So the okay. Let's see. So right. So basically, this method upvartize. The reason I'm talking about all this is if it's getting called during type checking before we have inferred everything, that could be a problem. So I wanted to look over these call sites and see whether they fall into that, like where they happen in the pipeline. So this one is mere construction. That comes way after type checking. That's fine. This one is a little bit different. So this, some of these uses, this is part of trait and type check. This actually occurs during type checking, although it occurs very late in type checking. So I think all types have been resolved by this period. But there's something interesting about this, which is that a lot of the uses of upvar ties would actually be fine to operate on a tuple. Like what this is doing, this particular function is walking down, but basically examining all the data that's inside of something, right? So if you're in a closure, it goes through and recursively processes the type of each upvar. But if you look right here, if it encounters a tuple, it does the same thing with the types in the tuple.
Right.
So actually, we could have another method like upvar tie tuple that just returns the tuple of all upvar types and doesn't try to sort of dereference it and iterate through the internal types. And that we can do no matter what, because it might be an inference variable, but it's just a single type no matter what, right? So the reason that the inference variable causes a problem for the current signature is that we would have to sort of open up the tuple, if that makes sense. And we have to know what it's bound to. But if we just have something that says, give me what is now or will eventually become the tuple of all upvar types, we could use that here and in a lot of other places, I think. Does that make sense?
Yeah.
So similarly here, well, what's this? I think that here, yeah, we could also, this could be as well the tuple. Right. This debug info, this is way after type inference, way after. Similarly, this, all this code comes way after type inference. Layout also, I believe layout already sort of, so layout is what computes like what fields of a struct occur at which offset and so on. And
Memory layout, is it?
Yeah. And you can see here that layout already fails if it encounters a type inference variable and bugs. So this must be after type inference as well. So we don't have to worry about that. Now trait selection, this is a little bit different. But this is another, so this code is saying when is a closure copy or clone? Right, and a closure, basically some closure type C implements clone if all the upvar types are clonable. But we could again use the tuple type, right? Today we sort of do that, but we could instead do something like and that's true because tuples are clonable if all their constituents are clonable. In fact, you see the code right here. So that's good. Similarly, I think this is just fine. I think all of these cases can also be a tuple, and it's fine. I think I looked at them before. Similarly here, so this is computing what, these are like well-formedness conditions. So if you have types, they have criteria for them to be valid. So like maybe this, oops, something like this. This is not actually true, but it might be that for this to be valid, k hash must be true or something. Right? I think the actual hash set does not require this, but this is the code that would compute it if it did. And I think again we could use a tuple here. Fine. Similarly, this code, if I'm not mistaken, can use a tuple. This crazy code. Okay, yeah, this could again use the tuple. I think it also comes after type inference. This is pretty printing. I don't know. This one's a little tricky because pretty printing happens at any time. So we'd have to we probably have to adjust this code to account for the possibility that it doesn't know how many upvars it has yet at the point where we're pretty printing.
So what is PAUX?
It's the pretty print auxiliary. It's a horrible piece of code, but no one's ever figured out a way to make it nice. It basically prints types in a user-readable way.
I see.
It's not. I mean, it's kind of hard for us to print things like a closure type anyway, since they have no syntax. But
so this is the code that get invoked when you do that colon and question mark. Then this one figures out how to print. Is it
this code? No. This is used when you're printing an error message in the compiler.
Oh.
And you have to print a type out.
I see.
So that you can tell the user what it is.
Hmm.
Yeah, blah blah.
So what is the verdict on this one? Like, can we change it easily? I didn't get that part. You said it's horrible code, but can it?
I think we will have to do a little bit of. I think what we want to do in that case is to.
So it's an open question. Do you mean to say that? Like, we'll have to figure it out as we go.
Well, I think we just have to make it able to check whether basically, yeah, I think it has to degrade gracefully. So I think what I mean is I think that code needs to look at the type, and if it's an inference variable, it just won't print anything.
I see.
And if it isn't, it'll handle it. So, and that'll happen. Because it might, I don't know when it gets called, but it might get called. If nothing else, it can get called in debug output at any time, basically.
Yeah.
This is still after type checking. Well, this is a case where we can use the tuple. So yeah, after. So I think it should be fine. Didn't find any case that made me too worried.
So there is no case where it is called before type checking?
That's right. And it is called during type checking, but only very late when it should already be known, or in all the cases where it's sort of ambiguous, I think we can make them almost all operate over the tuple and they'll be fine.
Okay.
So let's try it. I guess we'll find out. So the first thing that needs to change, I mean, we'll start by changing this closure subst struct. So we'll say upvar tuple. So basically where we were giving a slice, we're now going to expect there to be a single argument. And then here, the upvar ties. So let's make a new helper. So this helper will give back the type as a tuple of upvars, right?
Correct.
So here, I'm going to change this signature also, so that it can't be called during type inference. Because the okay. So what we're going to do now is this is giving back an iterator. Oh, okay, I guess we'll keep that. We're basically just copying this this setup that other parts of the code have. Right, so we'll call the upvar tuple type. It should be a tuple of types, and we can call this. Okay, you with me so far?
Yeah.
Right. So let's. So actually, let's do this. Let's do this in somewhat smaller steps. Sorry, what I'm doing here is reviewing my Git history. I'm going to leave this comment alone. We'll hold off on editing the comment until we actually know what approach we're doing. But what I'm thinking is, what if we leave everything the same, but we'll just introduce the upvar tuple type helper? Or no. We'll do this. So we'll keep it so that we have a kind of unknown number of upvar substitutions. But we'll make a tuple type of them. And that way we can adjust the sort of the code that uses this without independently from the rest. That makes sense?
Yeah, right. So we can modify one case at a time.
Yeah. So I think to make a tuple type, let's see. What? Oh, sorry, I'm just going nuts here. Okay. Alright, I guess I don't remember the name of this function. To make a tuple type, we do it somehow. Let me see. So it's Rustock. It used to be called make tuple or something. Oh, okay, it's called mk2. So let me show you this function. So there's a function here to make a tuple that takes something that can be interned as a slice of types, I guess. So what we'll do is we'll so I've got this list of kinds, basically. And I have to kind of convert it to a list of types. Basically asserting that there actually are types and not lifetimes. And now I think this should be enough. Probably need this to be just a second. So I think now I can call make two upvar types. see what happens. In theory, this will not probably build. I'm just going to call xby check. So this is, if I can, my preferred way to build with the compiler is, refactoring things that I only have to check if it builds. I don't need to actually run it as much as possible. Yeah. And then maybe go back and run the tests, and if I have a bug, do like a bisection or something.
So your build happens like so quickly. For me, it takes like 5 to 10 minutes, and I have a, I think a top.
Are you running check? This is check, mind you.
Oh, okay. I do x.py build.
So you probably could be smarter about the command you run. Also, nice. But that's kind of what I'm saying is that I like to use check. I like to set up my work so that I can use check and just do type checking. In part because it's much faster.
Okay.
And of course, it's also nice. Like it leads you to a sort of series of small changes that are independently processable.
Makes sense.
Okay, so now I have some weird, annoying. What is it? I don't even know what this code is. Upvar subst. Okay. I see. Okay. So this code is just trying to sort of be generic over two kinds of upvars. And I didn't realize that generator subs was their own struct. That's going to be a little annoying. We'll deal with that. So the reason is I wonder why it's an impl iterator. Well, it makes sense. So the problem is impl iterator means that you have one iterator type, but there's actually sort of two possible. I'm just going to implement this in a slightly different way. So this is basically saying you're getting your subs from one of two places, right? And in theory, you could write this. You'll see that this doesn't actually build. But we can tweak it to make it build in a second. I don't know if this makes sense, but saying depending on whether you have a closure or a generator, you have slightly different types, but they still each have an upvartize method, so we could call it like this.
All right.
In practice, right, this is the problem. The problem is they each have a different iterator type, and we need to return exactly one iterator type. I don't know if you've worked with infiltrate, but this is the problem that occurs sometimes. We use either already. We must. So one way to solve that is you can use this either type,
I see.
which basically it's kind of exactly this. To be honest, it's like exactly the same as this upvar subs type. It's just an enum with left and right, and it implements iterator if left and right both implement iterator, and it does whatever it dispatches appropriately. Have you seen that before or not?
I haven't. So that's a standard library.
It's
like
no,
it's compiler only did.
You see, I'm adding it to the cargo taml here without telling you, but
yeah.
It's a it's a crates.io crate.
Oh, okay.
But a pretty handy one.
So we are fine picking up a dependency on it.
We already have.
Oh, we already do.
Just not in this particular crate, but other crates do. So yeah, I'm just taking what's already there. If you see here that librussy mirror uses either.
I see.
This is a ripgrep output.
Okay.
One of my favorite tools.
Yeah, I didn't know it until I saw one day you post something on Zulip about RipGraph, and then I downloaded it. It's pretty neat.
It's handy. Okay, so now I'm
You
getting.
you cannot ignore things there, like directories stuff.
Right. Oh yeah. Well. Okay, so now that code is all building, but we're getting errors because I made this. I made it so that the upvar ties helper method can only be called if you know that you're not doing inference, which
Right.
it's getting us some compilation errors we're about to see, which I think is okay because these are exactly the cases where we can try to use the tuple type instead. Or at least some of them are. We'll see how it goes. So like here, I think we just need. So I'm just going through these and changing them. To use this upvar tuple tie where appropriate.
And you also added that trivial drop check outlets.
Yeah, so if you look at this code, what it's doing is it's going through each of the upvar ties, and for each one, it's calling trivial drop check outlives.
Right.
So what I'm doing instead is I'm calling trivial drop check outlives on the tuple. And then that will cause it to iterate. Does that make sense?
Yeah, that does. Thanks.
Similarly here, I can, instead of iterating through the list, I can just I can just call it once.
Yeah, makes sense.
I think the same here will work. Okay, so this is what's happening here is the TCX has all these lifetimes. Have you seen the whole what they represent?
Yeah, I read that on the Rusty guide.
So
never really used it.
It so happened that the last one in the list is sort of the lifetime of the shortest life, basically the lifetime of the innermost enclosing inference context.
Oh, okay.
And it's kind of the lifetime of types that you're working with, basically. And it so happens that those functions didn't need to constrain it before because they weren't making types. So when you make a new type, it gets interned, it gets stored in the arena, and it gets that lifetime, the shortest one. But they weren't making new types, so they didn't really care. But now we are, because we're making the tuple type, so I had to indicate that this shortest lifetime, the types we make have TCX lifetime, which is what we are expected to be.
So the purpose of this is when this the innermost circle of code finishes executing, then we free all the memory, right? So was it the case that the previously we were not freeing memory?
No, it's just that we weren't allocating any memory in those functions, so they
Okay. They didn't need to free
need
it.
to say how long it would live, kind of.
I see.
Now I'm getting some weird problems. Why? Oh, yeah. No. So what I'm going to do, in order to avoid, I'm going to take out this. This is the requirement that was forcing us to not call it where it might be in inference code. I'm going to take that out because I want to get it working without, like, bit by bit instead of all at once. And I'm going to just go through now. This is the ripgrep output. I'm just going to go through and find places I think we can manually convert away from calling upvar ties, even if they would compile, because we know.
Let's see.
So this is like dot upvar tuple tie def id tcx. Oh, I see. So here again, I'm just converting what was an iteration
Right.
to a single call. I'm a bit confused here. That should work, I guess. This one I'm going to leave alone because this is a generator. We'll have to change generators too, but I haven't done them yet. So.
Okay.
This one I'll leave alone, leave alone. Should be okay. Incidentally, if we were going to change the memory layout, you know, I said we still model a tuple closure as having n fields instead of one field that is a tuple. This layout code is, if we were going to change that, we would probably be, among other things, changing the memory layout code. But anyway, so not here, that's a generator. Here I'm going to change this. So I think I'm going to have, just looking at the time, I'm going to have to go soon. But what I was thinking is once we get, hopefully we can get this building, and I'll push it to a branch. And then maybe you can try to, we'll have to discuss, but we should be able to sort of come up with some next steps.
Oh yeah, sure.
Oh, this is annoying. This is annoying. So, hold on a second. Let's try this. This is an annoying lifetime error that I will possibly just sidestep. So, yeah. So what's happening here is that in the pretty printing code, we have, we actually, normally we get given a TCX, the type context, as a parameter. And so we can kind of constrain its lifetime however we like.
Right.
Why is this dying? It's that. But in the case of the pretty printing code, we can't do that because we get invoked from a debug impl. So what we do is we grab the type context from, we use like thread local storage. And then we have to do some horrible things because we weren't given it as a type parameter, the compiler doesn't really know like what its lifetimes are and so forth. It doesn't know kind of what its full type is. So we're sort of doing some hacks, and that's what I'm trying to solve here. Unfortunately, it's not working, and I don't know why. But let's see. I kind of know why. So what happens is this tie TLS width says, give me the type context that's in scope. And you wind up having to give it a closure which works sort of for any lifetimes. And now it's getting unhappy because it has to work for any lifetime. Oh, that did work. Okay. It has to work for any lifetime because it doesn't really know how long the data is going to live after all. And yet we told it we're basically combining data with one known lifetime and confusing it. So what we have is we have this scheme. If you see this, where did that code go? So here where I call tcx.lift, what that does is actually uses a little bit of unsafe code, but it basically checks dynamically that the data that we're lifting was allocated in the right arena, and it will return none if not. And so it kind of lets you bridge this, where a compiler doesn't know that these two things are the same. This kind of dynamically checks it and lets you assert that they're the same by unwrapping. So when I call tcx.lift subs.unwrap, I'm saying basically check that this is in the right arena, and if it's not, then abort. But it will be because there's only one arena, so it's not. We know that, but the compiler doesn't know it.
I see.
Don't worry, that's like super voodoo. Okay, so hopefully this will build now.
Yeah, it is building.
It's getting somewhere. So start to, or introduce upvar tuple type and use in some places. So let's take the last 5 minutes. I'll push this to my. Let's take. So the next steps. So what we did today is we introduced this upvar tuple type. I think I called it more or less everywhere that we want to be calling it. I think all the rest of these locations, almost, with one exception. What's this? Yeah. So, okay, there's all the rest of these locations that call upvar ties are fine, except for two things. And by fine, I mean they come after type inference.
I see.
Except for two things. First, some of them are calling on a generator. And I didn't convert. I converted the closure, but not the generator. So that needs to be changed. We probably just need to change the generator the same way, and that might be a good next step to like replay these steps that we just did, that I just did real fast. And you can try to do it yourself, and that will help. But the other thing is, this particular usage here is this is actually in the type checker in the very last phase where it's exactly the phase where it figures out the kinds of, like, basically where it infers all the upvar types and everything. So we're going to have to update this eventually, but we don't have to yet because we're doing this intermediate step where we just have a tuple. So I think what I would say is the next steps probably are, so first I would change the generator subst here.
Okay.
So that basically this, what we did today was we changed the closure subst, we introduced this code to make a tuple, right?
Right.
We do the same thing here in the generator subst split. It basically wants the same code. It's a little bit different because the numbers are different. Generators are a little different, but same idea. And then once that's done, we might want to change the pretty printing code.
Okay.
Because right now it's assuming that you know how many upvars there are, and we want it to. We basically want to rewrite this code to. So I'll do something here. So fix me. Rewrite this to call upvar tuple tie and check the result. If it is an inference variable, we can't print upvar information yet.
I see.
Else we can extract the types from the tie tuple. You might want to add, like, maybe add a helper like upvar ties or something that returns option. I don't know, just to like encapsulate things a little better. But
sure.
That's one thing, and the same. That's for generators. The same logic applies here for closures. Maybe we'll. I'm going to write. That's your username, right?
Yes. Yes.
So it's easier to grep through. And then we said we should change the generators. So once we do, I think I don't know if this will work, but I would like it if we could change this signature to this to prevent this from being called during inference. If we were going to do that, we would need to update the PP, the pretty printing code, at minimum, which is we just talked about. So once we do that, then we're basically ready for the next step, which would be to actually make it a tuple from the beginning. And we should just talk again.
Yeah, sounds good.
All right, cool. So here's what I'll do. I will push this branch. I will post this video in case you want to review it. And we'll talk after that.
Yep, sounds good.
All right. Talk to you later.
All right. Thanks a lot for your time. I really appreciate that. Your time is really valuable.
It's fun to see this. I hope this. I look forward to this feature. All right.
That's good.
Yep. Ciao.